Hello, greeting to you, sir. How are you? Myself, Naveen Kumar Pardeshi. I am a BTech in production engineering from Sri Guru Gobind Singh Ji Institute of Engineering and Technology, Nanded. It's an autonomous institute. I have done it in production engineering. I have been into teaching since 2012. At that time, I used to teach mechanics, SOM, M1, M2, M3, like that subjects. And after that, in 2013 and 14, I got into teaching class 8, 10, 9, 10, 10th for State Board Maharashtra. And when I got graduation, after the graduation, I started teaching in Nashik. In Nashik, I have been to Sai Samartha Academy, and there I worked for 1 year teaching class 9th and 10th state board, and I have also opened my institute at that time. Then I went to Pune in 2019. In Pune, I have taken several home tuitions also, and in Brainiac Academy, I have teach for class 11th and 12th mathematics and physics. Okay, for 1 year there. And I have been taking home tuitions of class 11th, 12th, and as well as class 10th, and teaching subjects like maths and physics. But physics is a personal good subject. So after that, the lockdown occurs. And because of that lockdown, I went to my village. And there I started teaching in a school and also in the academy, Samarth Academy. The name of the academy is Samarth Academy. And there I taught from class 8, 9, 10th foundation and class 11th and 12th, Maharashtra as well as CBSE board. Okay. And while doing so, I just got an interview from the Byju's and got selected here for teaching class 5th, 6th, 7th, 8th, 9th, and 10th. Okay. I teach as a physics faculty here, and I have applied for teaching the foundation course for class 6th and 8th, 9th, and 10th onwards. So that's all for me. And I'm going to give a lecture today on Newton's laws of motion. So here is a PPT that I am sharing with you. Okay, let me complete the procedure first from the beginning. Okay, so here myself Naveen Kumar Pardeshi and I am teaching physics here, and I'm going to teach the laws of motion. Okay, I'm going to teach the first Newton's first law of motion, then what is force, what is mass or inertia, what is Newton's second law as well. So keeping it a very short, I'm just giving a little demo that will show my teaching skills. So here, what is dynamics? There are two branches of physics dealing with the motion, that is dynamic and a kinematic. Okay, what is dynamics? It contributes to the relationship between the motion of object in our everyday world and the forces acting on them. Okay, see here, it also include the forces acting on them. Okay, language of dynamics. See, here are the language of dynamics. First of all, force, the measure of interaction between the two objects. That is, any push or pull on an object can be considered as a force. It is a vector quantity. It has a magnitude and direction. Yes. The second is mass. Yes. The measure of how difficult it is to change the object's velocity, or how difficult is it to change the object's position. That we can say that it is an inertia of the object, mass. So that's all the language of dynamics, force and mass. Now going toward the force. Force is the measure of interaction between the two objects, push or pull, as we have already learned. The vector quantity has magnitude and direction. Maybe a contact force or a field force. See, forces can be applied by direct contact or by indirect, non-contact forces. And that non-contact forces acts in a field force. So contactless forces results from physical contact, and field forces act between the disconnected objects. Oh, can I have some example for the contact as well as non-contact forces? Yes, contact forces, you can say that it's muscle force, mechanical forces or contact forces. Yes, what are field forces? Yes, as you have all learned, the gravitational force is Even if we are not in contact with the gravitational force, it still acts on us. Electrostatic force. We had not seen that electrostatic force, so still we are going to learn much more about that force now. Magnetic force. Yes, magnetic field everyone had must experience. We used to play with magnets. So we have not just touched the object. There was no contact and still we are able to move that objects. So that is non-contact force. So we are going to learn about the gravitational force, arithmetic force, friction force, tension force, spring force, and normal force in our chapters. Okay, these all forces have some significance for your syllabus. Okay, gravitational force, Archimedes force, friction force, tension force, spring force, and normal force. So now, vector nature of force. Okay, vector force has magnitude as well as direction. As you all know, scalar has only magnet. It can only be scaled, but vector has magnitude as well as direction. Okay, we will get it further, not wasting much time. So net force, a resultant force acting on an object. F net is equal to summation of vector sum of all the force. Oh, what is vector sum? What is a vector sum? You need to have knowledge of vector sum also while doing the problem of these forces. You must use the rules of the vector addition to obtain the net force on an object. So these are some formulas. Magnitude of force is given by under root of F1 square plus F2 square if the two forces are perpendicular to each other. Okay, the angle made by F2 with the resultant force. This with the resultant force can be given by theta is equal to tan inverse F1 by F2. Okay, you need to know some trigonometry also. Okay, so these are the requirements. You must know the vector sum and you must know its formulas also. Okay, if we are okay with it, we must go along. So what is Newton's first law of motion? Yes, we know that every object remain in the state of rest or motion until and unless an external unbalanced force acts upon it. So what actually Newton is about to say? If this is an object at rest, it will remain at rest until and unless an external unbalanced force acts upon. What is an unbalanced and balanced force? See, he's saying that if this body, a body, is balanced, then the forces, the net forces acting upon it is zero. Then we can say that it is the force acting on A is a balanced force. For example, I say a 5 Newton is acting on this direction, another 5 Newton is acting exactly linearly in the opposite direction. And we say this 5 Newton nullifies this 5 Newton. So the force acting on this object A is totally balanced. So it is not moving. And an object in motion, this is the interesting part. If the object is in motion, it is already in motion, it is moving with some velocity E. Then also, the then also there is no unbalanced force acting on it. How, sir? An object will need force to move, na? Yes, an object will need force to move or change the velocity or change its position, but not if an object is already moving with the velocity of v. If the velocity is constant, we can say that the net force acting on the body is zero. That's what Newton concluded. So again, an object remains in a state of rest or motion until and unless an external unbalanced force acts on it. Okay. So see, here you can see with an example. This is a person in the car. When the car was moving along, not the car, not the person was getting affected, but just when the car hit the wall, the man began to fall forward. Why? Because the external force was only applied on the car, but not on the person. So as the person was moving forward, no external force was applied to the person. The person resisted the change in motion and then he get forward. So Newton's first law of motion, an object at rest tends to stay at rest and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. So when the forces are balanced, the acceleration of the object is zero. Yes, simple. Object at rest, velocity is equal to zero and acceleration is equal to zero. That is summation of f is equal to zero. Okay. And object is in motion, still if velocity is not equal to zero, but acceleration is equal to zero, then also summation of f is equal to zero. Okay, there is no external unbalanced force acting upon these two cases. So net force is defined as the vector sum of all the external forces exerted on the object. We will see that. If the net force is zero, the forces are balanced. And when the forces are balanced, the object can be stationary or moving with a constant velocity. Remember this, an object, whether it is stationary or moving with the same velocity, both net force is equal to zero in both cases. Okay, at rest or with constant velocity. In both cases, summation of all the forces acting on the object is zero. So mass and inertia. Let's get through the mass and inertia. Every object continues in a state of rest or motion until a motion in a straight line unless it is compelled to change that state by unbalanced force impressed upon it. So isn't it seems like inertia? Inertia is the resistance to any force. Inertia is the property of an object to resist the change in its motion or rest, you can say. Okay, there are two types of inertia, the inertia at rest and inertia of motion. If body is in rest, body wants to be in rest. If body is in motion, body wants to be in motion with constant velocity. That's his inertia. He wants to be himself. If he is at rest, want to become at rest. If he is in motion, he wants to travel in that motion only. That's what teenagers do, na? They don't like to hear anybody. So mass is the measure of amount of inertia. How much inertia does that mass, that body consist of? Okay, mass is the measure of the resistance of an object to change just in its velocity. Mass is an inherent property of an object. Okay, it directly comes with the object when it is born. Yes, scalar quantity and the SI quantity. It is it is a scalar quantity. Its SI unit is kg. Okay. Next, Newton's second law. The acceleration of the object is directly proportional to the net force acting on it and inversely proportional to its mass if mass is constant. Yes, if I can be more precise, the rate of change of momentum is directly proportional to the applied force and acts along the motion. This is the Newton's second law, and while we keep the mass constant, we get this formula. Rate of change of momentum, mv minus mu. This is change of momentum and this is its rate, is directly proportional to the applied force. This is the formula that we get. And by taking the mass as a constant, we can get this second formula also. Units of forces, yes, as we all know, the unit of force is Newton. N, it is denoted by capital N. 1 Newton is equal to 1 kg meter per second square. So what must be its unit in CGS system? So for converting it in CGS system, we have to convert everything in CGS. See, if I say 1 Newton, okay, is equal to how much in CGS system? Then say 1 kg. See here, it is kg. So I will convert 1 kg in grams. It will be 1000 grams. Yes, into meter. Meter to centimeter. 1 meter is equal to 100 centimeter. Correct. Second will be second. So 1 Newton is equal to 1000 into 100, 10 raised to 5 gram centimeter per second. So we can tell that gram centimeter per second is equal to dyne. So 1 Newton is equal to 10 raised to 5 dyne. That is the CGS unit of force. Okay, 1 Newton is the SI unit of force. F net is equal to summation of all the forces, that is mass into acceleration. So something more about Newton's second law. You must be certain about which body we are applying to it. First thing, किसने किस बॉडी पे फोर्स एक्ट किया. We must know who is applying the force and on which body the force is being applied. F net must be a vector sum of all the forces that acts on that body. सिर्फ उसी body पर का vector sum of लोगे. Okay, we will consider each and every force acting on that body and take the vector sum of that. Only the force that acts on that body are to be included in the vector sum. The net force component along the axis gives rise to the acceleration along the same axis. Okay, if net force is in this axis, then acceleration must be in this axis only. Okay, there is a sample problem and we must do it very fast. So sample problem says that okay. Sample problem says that one or two forces act on a punk. Okay, moves over the frictionless ice along the x-axis in one-dimensional motion. Okay, then puck's mass is m is equal to 0.2 kg. And the forces F1 and F2 are directed along the x-axis and have magnitude F1 is equal to 4.0 n and F2 is equal to 2.0 n Newton. Forces F3 is directed at theta is equal to 30 degree and has a magnitude F3 is equal to 1 Newton. In each situation, what is the expression? Or let's take the situation number A. Okay, here we are taking situation number A. Okay, this is the body. The force acting is F1. F1 is 4 Newton. Okay, what is the mass of the body? It is 0.2 gram. Okay, 0.2 kg, sorry, 0.2 kg. Okay, so we know that if we want to find out the acceleration in this case, the acceleration is equal to summation of net force upon mass. Yes, so the acceleration is given by summation of all. See, there is only one force acting, so we need not to do the summation vector sum. So there is 4, and what is the mass? Mass is 0.2. Okay, so 4 by 0.2, how to do it? Okay, I will multiply it with 5. I will multiply it with 5, so it will become 1 4 5 is 20 meter per second square. Yes, that's all about A. Okay, now let's take situation B. Okay, if I'm taking the situation B, see, the force F2 is acting here. What is F2? It's 2 Newton, and to the opposite, in the opposite direction, F1 is acting. What is F1? It is 4 Newton. So I think so the total force on the body will be F1 minus F2 and in the direction of F1. Okay, 2 Newton. Done. So acceleration, now we have find out the net force. So acceleration is given by summation of F divided by mass. So what is summation of F? It is 2 Newton divided by mass 0.2. Again, it is 10 meter per second square. Okay, in the third case, see, F3 is inclined with an angle theta and theta is equal to 30 degrees. So that case is a little bit different. Okay, see, here is F2, F2 is 2 Newton and F3 is acting this way. Okay, at an angle of 30 degree. Okay, what is F3? 1 Newton. Okay, see, what will I do now? I will split these components. This angle is 30 degree, na? So just carefully look at me. It is 2 Newton. Okay, and it is connected with 30 degrees. So I will say that it is 1 cos 30 along this side and along this side it is 1 sin 30. Okay, so the acceleration will be in this direction. Okay, so F net will be 2 minus 1 cos 30. F net will be 2 minus 1 cos 30. This will be our F net in this direction. Okay, so my acceleration will be summation of F upon M. So what is summation of F? 2 minus 1 cos 30 and divided by M, mass 0.2. And that's all. You have to do it by yourself. Cos 30 to root 3 by 2. Just find out the answer and leave it in the comment box. And have a nice day. Nice talking to you. Okay, wait. Thank you.